Hi, I'm Andrew Martin, the president and founder of Blue Rhythm.
What we help our customers do is organize forms, workflows, checklist inspections, their whole project on a digital platform in the cloud.
One of the unique things about Blue Rhythm is the amount of flexibility in how you structure your projects, workflows, equipment, forms, and checklists. Blue Rhythm has the flexibility to design any type of test form or checklist. It also has advanced features like validation rules using additional operators,
File request, review, approval, reject workflows that you can build directly into any type of activity intended for your team or guest users. And you can even incorporate equipment data collection that needs to be manually collected in the field.
Blue Rhythm report building tool is powerful and flexible. You can create anything from a quick issues log export to a complete final report, progress update, systems manual, or any significant documentation you need for a project. Thanks for watching, and I look forward to talking to you soon.
Good afternoon. My name is Karen Shunk with AABC, and I'd like to welcome you to today's Tab Talk webinar and thank our sponsor, Blue Rhythm, for supporting this session. I'd like to cover a few items before we get started. First of all, presenters will be holding questions until the end of the presentation, but we do encourage you to submit questions at any time using the Q&A button. If you happen to be experiencing any technical problems during the webinar, please use the chat function to inform our producer, William, who will assist you. This presentation is being recorded and will be available for viewing within about a week. And in terms of continuing education credit, everyone in attendance for the full webinar will receive a certificate of attendance into their email within 24 hours. And if you are a certified TBE, TBT, TXA, or EMP, your CEUs for attending any AABC webinar will be automatically uploaded to your respective portals after the webinar within about a week. Today's webinar is Fundamentals of Test, Adjust, and Balance for Engineers, CX, and Energy Providers with Mike Kelly, who is President of American Testing. Mike's careers in testing and balancing began at 14, working weekends and summers in the family business. And now a scant 10 years later, he's now professionally certified, working as a TBE and CXA, a former AABC board chair, and is currently serving on the AABC Fume Hood Certification Committee. Without further ado, I'd like to hand it over to Mike to kick us off.
Good afternoon, everyone, and thank you for attending the presentation. Let me see if I can do a screen share. Hopefully that's coming through loud and clear and easily seen. So today we're going to talk about some fundamentals for testing, adjusting, and balancing. We used to call it a primer for engineers, CX providers, and now energy providers. We want to thank, first of all, our sponsor today, Blue Rhythm, for sponsoring this webinar. We also call it Tab Talk. That's I guess a side presentation that AABC has developed over the years as a presentation description. Moving forward, today we're going to talk about HVAC testing, adjusting, and balancing. TAB is the process of checking, adjusting all of the environmental systems in a building to produce the designed objectives. ASHRAE Applications Handbook, Chapter 38 is the reference of where that came from. Test and balance is the art of displacing pressure or pressures. We wrote unknown TBE because it's kind of a description that AABC test and balance engineers and technicians like to use, that basically we're always checking for pressures, whether it's airflows, water flows, hydronics. Pressure always details where the airflows are going. So it's kind of tongue-in-cheek there. Test and balance is the art of displacing pressures. Moving on to the next slide. What is testing, adjusting, and balancing, or TAB? HVAC TAB provides a comprehensive examination of the entire HVAC system to verify it was installed per the contract documents and that all components work properly. This includes, but is not limited to, all the equipment listed below. So testing, adjusting, and balancing isn't just doesn't just stop there at construction. It goes on to existing construction, renovations, retro commissioning, retro testing and balancing, and diagnostics. We like to call it building forensics from time to time. So HVAC testing, adjusting, balancing provides a comprehensive examination of the entire HVAC systems in buildings, not just per construction documents and design intent. So testing, adjusting, and balancing is a more elaborate thing than strictly having to do with design and construction documents. Although many times you refer to the construction and design documents in your retro or your forensics investigation into HVAC systems, but it doesn't strictly stop there. But for the most part, it is a comprehensive examination. Why is TAB important? TAB is important because it will identify discrepancies in the installation and control of a system that varies from the design. We all know that to be true. We all know that to be tremendously important to find out if there are discrepancies. And if there are none, then you get a TAB report that indicates all systems operating normal and we're good to go. It's the times that we find out that there are discrepancies between what was the design intent and the installation that, could have happened in a perfect world but didn't, and a control system that could work in a perfect world but may not be for whatever extenuating circumstances. And of course, that varies from the design intent to the extent that they become broadcast openly as testing, adjusting, and balancing is performed. Without that, you really don't identify any of these problems or possible issues. As it states below, it can also identify possible issues with design not achieving the original design requirements. A properly balanced system is more efficient and will make a building run smoother. When we say a building runs smoother, meaning there won't be as many cold calls, complaints as we hope. Maybe there won't be systems operating out of their design parameters on extremely cold days like we had here in Maryland this morning. It was 10. And then, possibly by next week on Wednesday, it might be 60 here. So we hope that things are operating efficiently on buildings that run smoother and don't have major problems when there's a major temperature swing. Design review section. So we're going to get into some design review as it pertains to testing, adjusting, and balancing per the AABC requirements and expectations. Here to the right, we have a highlighted systems that show outlets, supply outlets, return, exhaust outlets. We have some equipment shown. We have ductwork shown to highlight exactly what is served by what, rather than black and white. And not too often do they get these from the design realm, designed personnel or team, but this is something that most testing and balancing agencies, whether they highlight the ductwork or they do this outline, it brings to light what's supposed to be, where it's tapped in. We see some of these taps for outlets and such. Are they, in transitions, just after transitions, at elbows? Sometimes you have an end of duct that comes down and goes out, and it goes from square to round immediately, and there's no shown volume damper because it's not a seal tight or a immediate connection with a volume damper in it with a duct takeoff, but it's a transition piece going from square duct to round duct at the end. And a lot of times those dampers get missed. That should get caught on a design review. The other thing that happens in a design review from a testing and balancing standpoint is duct sizing. We know that this ductwork coming out of the air handling unit and the blue duct is such a size, and does it increase? Is the aspect ratio correct? Meaning it's not 36 inches wide by 4 inches tall. Is it the correct sizing for velocity, meaning it didn't get squished down to take the velocity, well over and create a pressure drop that the system can't handle unexpectedly. Not to say we're design experts, but it's nice to have a good second set of eyes or third set of eyes on a system, anything that you design. I know oftentimes when I have a hobby of working on antique automobiles or cars, and you find that I did this right to what I saw, but then somebody else looks at it and said, why didn't you run across here and down? Why did you run it here and over? I was looking to come, Florida to South Dakota, not Georgia to California. So sometimes there's a better way of routing things or not, sizing things correctly. So part of the design review is that. Pre-tab report review. So during pre-tab or design review, we review the basis of design versus the design intent versus actual. Review project specific tab plan and strategies. To get acquainted with the what, why, and how when equipment and systems are to be tested. Gives you an idea of how we're going to strategize and get to balancing these systems after we've done our design review. Is everything accessible? Is everything installed correctly? For balanceability, that's a term that's been used over the years to say, can we actually balance this system, or are all the flow meters installed tight to the slab and we can't get the fittings on, our test fittings on the ports for the test ports for the flow meter because all the valves and the handles are pointed straight to the top deck and we can't get our instrumentation on it to test water flows. Is all the ductwork 9 feet above a drop ceiling, and no ladder in the world will get you 9 feet above the ceiling to adjust the dampers, i.e. we need remotely operated dampers or accessible ceiling that will allow a ladder or scaffold to get to that. Balanceability is the idea that those strategies and the equipment, can we get to it? Can we balance it? Are the filters accessible? Can we get to adjust the outside air, return air dampers, or to even perform testing? Are things accessible? I know I've said that a couple times here. Accessibility is a huge thing in new construction. It's very easily overlooked in the testing and balancing field to say, oh, we put it all in that room, or we put it all above the ceiling. It's someone else's problem to get to it and test it. Well, if we can't get to it to test it, it's not going to get tested. Or it'll get tested in such a flagrant manner that it may not be exactly accurate. And now we're jeopardizing accuracy over accessibility. Review current updated blueprints, modifications, revisions relative to effects on tab. All too often we know we get blueprints, they've been updated as built, get modified, and then we're the last guys or the last people to know on the project. Oh yeah, that's all been changed. You have outdated blueprints or as built. Very important to have those before you start any testing and balancing, and that's part of the pre-tab review. Review specifications for tab requirements. I'm assuming everybody understands that, but there may be some issues with specifications that your tab requirements are relatively simple in the job, but then there are some others that need to be spelled out in the specification to say, how do you want this tested? How do we want this specific system tested? Whether it's a biological safety lab, whether it's a containment facility, shouldn't be much too specific on common retail office space or office building. But when we get into specifics, specifications for the tab requirements should be spelled out. Discussions with installation team, designer, owner to determine extenuating project circumstances that would have effect on tab in a positive or negative manner. Like I just discussed there, it's about blueprints, project specifications, tab requirements. What in a positive way or a negative way will this affect tab, and how do we get you what you want at the end of this project? Many times variations can occur between design and install that will affect perception of what the tab report should indicate. Ask questions to clarify confusion. this isn't too self-explanatory to the extent that there are things that are seen with the testing and balancing industry that will affect how we get to the final numbers. So later in this presentation, there's a thing that says, why do we obtain this and what are we looking for? It should be discussed and brought to the attention of everyone. How would you like this heating water system tested in the summertime? How would you like the chilled water system tested in the wintertime? So your system's down, you don't have water in it. What's the effect? How are we going to do this to get the clarify? You know, you want to balance, but you know, it's January and the chilled water system is off. Or they have it drained down, or they don't want to run it so we can't get temperatures. What do we want to do there? And there's many other extenuating things, but that's a great time to start talking about it in your pre-tab report review. Project document review, I talked about that a little bit. We want to compare the system design to the equipment selection, system installation, system operation, and proper use of tab instrumentation. If we stick with these 4 top bullet points here, system design, equipment, installation, and operation. If we design a system and it's, let's say, 10 ton, we know that's roughly 4,000 CFM, but we add up the system and it adds up to 5,800. Well, now we're expecting the unit to produce 20 or 30% more airflow than was designed. Why? What's the circumstance here? Is the airflow over because somebody established dirty filter condition and there's going to be more airflow and we want to end up at dirty filter condition with 4 tons? So we're going to expect 5 tons out of this unit, or it's 5.5, 6 tons down the road. That equipment may not be able to handle that. So it's something that needs to be in a project document review established. Do we have the equipment for the system design? You'd be surprised how often we find out that some people just don't use calculators. But hopefully AI will fix all that down the road. We hope. Proper use of tab instrumentation. So that's a bullet point we put in there to know that it's up to us, the testing and balancing people on your side on your projects, to determine which instrumentation we should be using in these situations. Is it a velocity meter? Is it a capture airflow hood? Is it a duct traverse? Is it temperature drops? Is it pressure drops? All too often, we were on a project several years ago with York air handling units, and they immediately they liked that we had a traverse. They liked that we had face velocities on coils, but all they wanted to know was the pressure drop through the unit with dry coal. And they know at their factory, if this coil has this pressure drop, we know that it has this much airflow. And they took pressure drops and determined that we say this unit's doing 20,000 CFM. Your traverse is saying it's doing 16. We must have leakage between this pressure drop on the coil and where it goes down to wherever your traverse is on the discharge. And sure enough, we did. It was something that got overlooked in design installation. And, we also found it when we did I don't know what you want to call it, in-opt velocity test on the coil, but it also revealed that we had low airflow. But the way we were taking the velocities on the coils was not per their test method. So we ended up finding out that it was, in fact, a problem. But, not to say our traverse was wrong. It just didn't incorporate the fact that where the unit was connected and the roof curb, there was airflow leakage, and wasn't found until it was majorly investigated. We just thought the units were operating low and it missed the static on the design. But you got to use that instrumentation properly and know how and when you're going to use stuff. Tab specifications. Equipment should be identified for testing and balancing, meaning all equipment should be listed as to what should be tested and what shouldn't. Shouldn't be assumed that all equipment on the job is just going to be tested. If there's any kind of special or systems beyond air handling units, maybe it's a dust collection unit, maybe it's again, an isolation room, you know, a fan, maybe it's a HEPA filter of some sorts. Those should be spelled out, specific procedures for any testing equipment. I talked earlier about doing something in the opposite season, whether it's water flow or airflow. Pressurization, sound. Pressurization would be like sterile pressurization or room pressurization. It should be spelled out and left to say, instead of left to say, what does your local government say? Well, the design engineer, design team should have come out and said, we've already consulted with your local governing, and this is what the pressurization test should reveal. And this is what we're expecting. Sound and vibration, those things should be spelled out as to where, when, how. Air quality testing, not too much of that is spelled out in specifications, but we have seen it coming up here recently within the past 3 or 4 years. And we all know why that is. And then temperature logging, where, when, and how. You're doing temperature logging at 1 a.m., probably not too helpful to anybody on the job, but it might be the best way to do it because no one's around and doors aren't being opened and there's less disturbance, and you know that temperature logging is pretty steady in those hours. Well, that may not help you because we really want to know what happens during the day when people are there and doing business or utilizing the facility. AABC suggests specification of an independent tab firm. Why would you want the same guy that built your house to test it and say it's perfectly operating and running well? You wouldn't. Just like you wouldn't want your air balancing in your facility to be tested and adjusted and come to a firm conclusion everything is good by the guy who installed it. Why would he tell you, man, I did a poor job installing this? You're not hitting the numbers you were supposed to. It's unfortunate, but it happens all too often, and it's very, very important and well worth the money. There's not a super expenditure in this. Independent tab testing is, if you're not doing that, you're doing a disservice to your clients and yourself. Reports, details, and organization by systems. We're going to get into that again a little bit later. Approvals and paperless. Approvals anymore seem to have gone by the wayside. I know when I was out in the field for 20 years, approvals were big. Do you have an approved submittal? Nowadays, it's a reviewed submittal, maybe not approved, but they don't get paid nowadays for approvals. They get paid for reviews or just submissions and say, this is the air handling unit. Well, it doesn't have pleated filters. Well, we didn't specify that, or we weren't meant to approve it. They're supposed to read and know. So, and then the paperless portion, I believe that by the end of 2020s, everyone should be paperless if they're not already. You'll be doing a major disservice to your clients if we're not already paperless. Cloud-based for collaboration and construction team during the project for transparency. Well, all know how important that has become. And one thing I don't like, I like cloud-based, but I'm not a big portal fan. But that's just me. A specification that is reflective of the work being performed can be a powerful tool. You will get the proper proposals as well as communicating the desired work to be completed. Some tips are as follows. Have a specific job specification, meaning job specific, not boilerplate. You can't put the same specification out for a sub shop as you can for a 4-star restaurant. It's just not in everyone's best interest. Include reasonable tolerance that are consistent with the instrumentation ranges. We have this in there because all too often we have some unreasonable tolerances that are expected when your instrumentation can't withstand that, plus or minus 3%. Some instrumentation is plus or minus 3% full range. Well, when we're dealing in low tolerances in containment rooms or holding rooms or even operating rooms, isolation rooms, especially in COVID here, reasonable tolerances need to be considered. Outline any non-traditional testing procedures required, meaning anything that's going to be outside of your normal testing procedures, non-traditional, they need to be specified. Drawing specifications, latest issues may be different from bid drawings. We talked about that. Up current date, any modified as-built, shop drawings, submittals can contain needed info not on design documents. Sometimes the design documents drawings don't show pressure losses through equipment. They don't show pressure drops through boilers. The submittals will give you those details on chillers, air handling units, VAV terminals, flow control valves. Controls, you need to include controls, installer contact information so we know who to call in case we need to interact with their systems. Sequence of operations, man, that is a big one, and that needs to be reviewed and know that you're reviewing the approved and final. We're not there as testing and balancing agents to develop a sequence of operations or modify it. We're there to follow it. That's not our ball of wax that we need to be modifying. Change orders, RFIs, and necessary for job preparation. Construction tab commissioning schedule included. Completion and move-in, set targets and dates. Or sets target dates. Tab and commissioning schedule, they always run hand in hand. Anybody that thinks differently needs to reassess their ideas on what should be working together and what shouldn't be. Tab and commissioning need to work hand in hand on any project to make sure that while we're testing those systems, they're getting the idea of how they're going to commission them. And furthermore, if they should, because if it doesn't pass testing and balancing, it really shouldn't be commissioned unless there's an exception to the rule. What is needed to start? Tab technicians need to start the project with all equipment components installed, functionally operable, controls operational and accessible for adjustability. Accessibility means, do we have the software and the connection devices to access the controls systems for adjustability through laptops, tablets, whatever the case may be, web-based, Bluetooth, whatever controls need to be. Again, need to be with the commissioning guy and be hand in hand with the controls people. We need filters installed and systems flushed with strainers cleaned. Strainers and filters are in the same line, just different systems. And you shouldn't be balancing air handling units with dirty filters. You never want to be balancing water systems with dirty strainers. Specialty equipment, enclosures, and devices. We put in there labs, kitchen equipment, dust collection, etc. Labs is a broad statement. It could be operating rooms, could be lab fume hoods, a multitude of biological safety cabinets, any of those special equipments, they all need to be installed. Duct systems ready requirements. Windows, walls, doors installed, building enclosure completion, totally encloses zones and stairwells. This is not too much anymore, but we have seen many buildings over the years where they want you to start doing air balancing on some of these air handling units, and some of the windows are missing and the stairwells aren't finished, and we're having cross drafts and airflows and stack effect when it's cold outside, hot inside, or hot inside, cold outside. And the building's, drastically affecting this draft. It can affect your airflow and your testing. Total system energized, meaning everything's energized. We're not running off of, well, we have the SPY fan running, but the return fan's not ready yet. Can't balance it. I mean, you can, but it's not going to be accurate. You're fooling yourself to think this is going to be a great total system balance at the end. VFD started, completed, correct heaters installed. This VFD startup complete is very important nowadays. Don't overlook it. Oh, it's fine. They started it up. It's good. All too often, these VFDs nowadays are so complex with VFD startup that they can be limited on RPM. I've seen them where VFD is set up and it will only allow the motor to run its 80%, 90%. Well, it's running at 60 hertz, but it's only running at 1580 RPM, not 1750. Well, it says it's at 60 hertz. Well, the VFD is this voodoo thing out there nowadays. Absolutely needs to be started up by someone competent. All required filters installed and cleaned. We talk about that. Supply receive return outside air operating in sequence. We can't have some of the dampers operating and some of them not. They all need to be operating in sequence and ready to be tested. If you don't have all of this done, you really shouldn't be balancing any duct systems. Piping systems are very, very, very similar. System filled to design. Do we have the pressure at the bottom that's required to make the system full? Flushing activity, strainers, controls work in auto, fully powered systems. Again, just like an airflow, we're in this building enclosure. Can be incomplete unless specified because you don't have the airflow problem. But just like an airflow and duct systems, if you don't have all of this completed, all these bullets, you really shouldn't be working on the water balancing. Okay, system design selection. We threw this in there because we've seen things. Over here to the right, you'll see someone holding a capture flow hood over an outside air louver. Does anybody really ever want to see that? I mean, if that's all you got and that's what we're going to do and everybody's going to buy into it, okay. But not on my building, not something I would want done. I mean, I know what I'm looking at for airflow, but there's so much correction here and factor for error. Mind blowing. Down here to the right, we have some airflow monitors, some dampers, and this is the only way we have to test airflow coming in for this big outside air. These are two outside air intakes. One's a minimum, one's the maximum. How do we test airflow coming into these? Can't get a traverse anywhere. You surely can't get in there to do velocity testing. And if you could, what would be your factor and what's the area? So we're at a major crossroad here about how to accurately test outside air coming in on this second picture. Is there enough ductwork for a proper traverse? Does unit configuration allow for proper air measurement? You know, when we have these situations, again, right here to the top right with that picture and down to the bottom right, the answer is going to be no. And there should be a note in the report that says unable to establish accurate airflow measurement due to insulation restrictions. Can outside air be measured to rooftop unit? Is the rooftop unit configured and installed for outside air measurement? We have a project now where they ask us to read the rain hood, outside air intake hood on the roof with a velocity measurement instrument. Well, some days when it's 10 or 15 mile an hour winds, they call off the airflow outside air testing and commissioning because it's going to affect your readings. Sometimes they've asked us to build tents on the roof around them. So we have I don't like any of it, but that's what the owner wants. And that's the only way we're going to get true outside air. So they say, I don't like it, but that's what they require. And trust me, it's not a great feeling, but it's documented in our report. That's how they wanted to test it. And that's how we've done it for them. Would there be a better way? Absolutely. Do they want to do that? No. So they get what they get. If mixed air temperature method is utilized, can an accurate mixed air temperature be measured? That happens a lot. And I say, yes, there is a way. It's time consuming, it's tedious, but it is an accurate way to get mixed air temperature method utilized for accurate airflows. But it does take time consuming. There's an art to it. You have to, understand where your airflow or temperatures should be taken and shouldn't be taken. Stratification is always an issue. Static pressure profile of the rooftop unit, outdoor duct equipment, make sure factory or weather port test ports are installed. Yeah, that doesn't happen a whole lot. We like to ask for them, but if we do make static pressure profile and you do take statics, which we do on every piece of equipment, because if I don't see test ports and plugs on our equipment, I'm assuming we didn't take pressures, and that is never a good thing. Next, system design equipment selects traverse locations. So this on the left-hand side kind of shows you about a plane suitable for flow measurements. 75% of the velocity pressure readings are greater than 1/10 the maximum. This is all for testing and balancing, but this is showing you what our criterion is for when we measure what we should be looking for, what's a good traverse and what's a bad traverse. alternatives to duct traverses, because duct traverses are our main source of accuracy. Face velocity readings of filters and coils, summation of airflows at individual outlets, and summation of calibrated VAV boxes. Those are all great tools to use. Are they exactly accurate? No. Are they getting you in the ballpark? Absolutely, yes. If we've already calibrated the VAV boxes plus or minus 10%, and we could summate all of the computer or VAV box airflows when we get them read back, we already have a plus or minus 10% error, but we're within plus or minus 10%. So if we know that going into the job, we could start balancing at 0 to plus 10% on all the VAVs. And now that gives us a tighter range of accuracy, knowing at the end, we're going to need to use all of those calibrated numbers in the computer, in the control system, as our total air for an air handling unit or a rooftop unit. So making sure you know that going in rather than knowing it at the end going, oh, I didn't know I couldn't take a duct traverse because I didn't see any, I didn't think to look for straight duct. I just went and did the outlets and the VAVs. That's part of pre-balancing and knowing what you're looking at. Here's some examples of balancing dampers. I like all of these. I also like the Rossi, which isn't in this picture, but I would like to modify it and add that later. I don't like wing nuts. I know it's commonplace, it's cheap, but I don't like them. They vibrate, they move, they break off. This solid shaft over here to the right with the standoff is a great damper, but again, depending on the system and the velocity and how oversized or how much you have to damper this, these do move as well, along with the one here to the left. I like the flange part, but I have known this to be true. Sometimes they have put this on the duct, cut the round on the left slide here, or the left picture. They cut this round 8-inch hole, but if you notice the fitting here on this left picture has a flanged, almost of a conical shape. Well, if you put that round hole and then you put this large conical, air blow by it like a Coke bottle, and it'll actually suck air in through that hole. And we were on a job one time in Rockville, and they had to change all of that because they had conical fittings. The sheet metal guy was flipping it around, drawing the circle, cut the hole, put the conical fitting on. We had problems getting airflow in the whole place, and finally pulled some flex off and was like, uh-oh, it should be cut full size back here to this size flange, not the size of the 8-inch round. Different testing situations, new construction, air handling unit replacement, boiler installation, and individual space remodel. These are all examples of how jobs can be different from each other, and they vary in complexity. So whether you're doing a replacement air handling unit or a new construction, you can see here new construction is every component needs to be addressed and tested and balanced. If you're just doing air handling unit replacement, they may only want a minimum of the unit. We don't want to retest the airflows at all the diffusers because we know what it was previously. We just replaced the units on the roof. We want to get back to total airflow. Chillers, boilers, same thing. Do we need to test all the coils? No, we just want to know we got the pressure drop at the chiller. And then individual space remodels, we all know what they are. We'd be testing small spaces with available existing site conditions. Again, can we get the airflow from the system? We do this at airports all the time when they take restaurants out and or kiosks in and change things around, as they always do in many airports. You're always doing some kind of small space remodel. Using the proper tool for the job. Again, this is up to the balancing technician. We need to know what is being tested and the results that come from the test. Understand that some instruments are more reliable than others. There are tolerances to all equipment, and use established techniques to minimize issues or discrepancies in airflow readings. And anticipating error, meaning you look at things, and this sounds like a purveyor of doom or a negative way of looking at things, but you got to look at things to say, this traverse isn't going to be good. It's coming off of that elbow, and this is the best we can have. Or, testing these airflows on all of this equipment, and we're going to have stratification here. We got to be wary of it. You have to anticipate it to know, hey, this testing is skewed because we had this anticipated error, and sure enough, it shows in some of our readings. Here's the proper tools for the jobs. Here we see a biological safety cabinet taped off with blue tape and plastic and a flow hood. Here we have another flow hood with a clear skirt. I hope it's blanked off at the bottom there on that outlet. Remember, a flow hood is a proportioning device. It's not an airflow quantity measuring device of accuracy. It's a quantity measuring device, but the accuracy, there always needs to be some sort of factor put on, whether it's a 1.0, a 1.1, a 1.05, a 0.85, a 0.95, meaning we got 100 CFM, but when I take the hood down, we got 105 or 110, because when we put the hood up, it restricts flow and air comes out of the outlet next to it. Again, they're proportioning devices. Have data. Understand what is meaningful data. Will the data benefit the owner and project? Try to think of how data will be obtained and what data will be required. Can the data even be repeated? Don't get hung up on getting data and numbers just to get numbers. Think about the system. So what are we doing here? Why are we getting all these numbers? What are we looking for? What's the end result? Are we just getting numbers to get numbers? Are we getting numbers so that the maintenance people can use them down the road? Are we getting this for retro commissioning? Are we getting these numbers to substantiate design versus install, new construction? And how would it benefit anyone, the owner and the project? They're great questions to ask yourself in the beginning to say, why are we doing this and what's the meaningful data down the road? Am I just gathering numbers to hand them to somebody and say, here's some numbers? We should really know what we're doing and why we're doing it. So elements of a test report. I'm going to go through this rather quickly. We have an executive summary, warranty, national standards, our national certification, table of contents, summary, list of discrepancies not corrected. Always look for that in a test report. If you see anything that doesn't have any discrepancies listed, but you see discrepancies in tab data, there's some lists or letters out there to someone. You need to know where they came from and why things haven't been fixed. You know, why are we off more than 10% or 5%? We should be including temperatures and everything when you see that. Air balancing shouldn't just be air balance. As far as airflow numbers, you should have temperatures to follow and double check things. Hydronics is the same way. You should have temperatures to substantiate the water balance. Testing equipment, list of calibration. What equipment did they use? When was it last calibrated? System schematics and diagrams. I hope we're all seeing that more and more in test reports. That you know, what systems did you test? What did ductwork look like? What was the hydronic system? What did it serve? If it's not a schematic from the actual as-built or design documents, did they make a diagram at least showing you what it served? First, second, third floor, or just all of the first floor? Tab report content, air, water balance recorded data for equipment and systems, manufacturer's model and serial number, locations. Data is HVAC system organized, meaning we shouldn't have all of the outlets in one section and all of the air handling units in another section of the report. What air handling unit serves whatever outlets or systems should be, you know, pages 10 to 20, and then 21 to 30 should be another HVAC system. Whether it's a pumping system, hot water, chill water, you just don't want all your flow meters listed, and then you got to search. Well, these are all the chill water flow meters. Where's the pump that says, you know, we got 1200 GPM? The pump says we got 1500. Well, if that was listed by system, there should be a note in there explaining how'd you get 1500 out of the pump, but only 1200 out of your flow meters. VFD hertz, calculated horsepower, quantities, CFM, GPMs, RPMs, amps, volts, calculated BTUs. Summary sheets are collaborative data detailing. Those summary sheets should show what the collaborative data was. We have all this info. What is it doing? Again, like that previous slide. Why did we get this? What's the collaboration on? We got all these numbers. What's the summary of the air handling units operating at, you know, 92% of design? All outlets have been balanced within 96%. You know, we're establishing that the unit has 6% duct leakage. although everything was duct pressure tested. Those summary sheets and collaborative data detailing, it should be listed out and it should be explained from a good balancing perspective why your system is the way it is from a balancing perspective. Controls verification, area, floor, space, pressure, building pressures. Controls verification is a new thing that AABC has adopted in the past 10 to 15 years. It should be listed in most testing and balancing reports if it's called out in the specifications. It's not something that you get for free to say, oh, we can do controls verification for free, just specify air balancing. It should be called out to say per AABC standards, controls verification should be applied. And there's a specification and a standard for that in the AABC. And then of course, any special testing, any additional testing detail. When you're reviewing a tab report, pay special attention to the executive summary. Understand the equipment tolerances, compare the tab report to the project specs, and unit static profile is included. I put that in there because all too often I see so many air handling units and so many air balancing done where static profiles aren't included on air handling units, and they're so important. It's such an easy task that doesn't get done, and a static profile sketch to show you pressure losses throughout the equipment, filters, coils, air handling, fan, discharge air, filters, reheat coils, whatever it may be, that should be in there. So that's my little thing I threw in here. Reading between the lines for a test report. This is not what to believe. Inclusion should be digital, paperless, pictures required for identification and pictures of traverse locations. Suggested points for immediate rejection, incomplete data, left out static profiles, no fans or pump curves to show you how these pumps or fans are operating. So when you see this kind of stuff and you don't get complete data, left out stuff, no schematics, it should kind of raise a red flag to say, well, what's going on here? All elements and equipment on the systems included. Is the data on each equipment complete? Test and balance reports should all be evaluated. Can you establish accuracy within a report? Do the test results meet the design requirements within specified tolerances? Do the testing results correlate with fan and pump loss? Those are things that you can look at to say, something's not jiving here. How did they get this with such low static pressure or head pressure on the pump? Why aren't we way high on water flow? You can kind of question accuracy there. Not to say that it's not going to be accurate, but that's a way to actually look at it and say, how is this possible? Deficiencies, like we discussed earlier, if you're not seeing proper deficiencies spelled out within your report, and you see them, you need to ask for them. I am running tight on time, so I'm going to skip through this slide. I'm going to skip through scheduling. Actually, I can go back through scheduling. There needs to be enough time allowed in the schedule for tab and CX work to be completed. Request tab durations early. All work must be completed for tab to commence, as we discussed previously. Scheduling challenges, can't express it enough. We're always asked to do 10 weeks worth of work in 4, just get more guys on the job, more technicians, and that doesn't work. It works to get a job done, but the accuracy and things get missed, and then they wonder why down the road is there a problem with the job, and they look back and they point a finger at the testing and balancing to say, oh, they messed up and didn't see this. Well, you had me running around with 18 different crews, and we had 10 weeks worth of work to do in 4, and then you cut it down to 3 because you had to do system flush or building purge or whatever it may be, and it gets cut short. And just like you don't want to do that on your commissioning, you should never do it on your tab. So scheduling is important, and it should always be. I know it's the nemesis of the job that people think, but should absolutely take a lot of scheduling and coordination to get done. What's the best formula for tab success? Why the objective? I think I answered the first question with the second question. How should deviations be handled, positively or negative? Approach all AABC reports with confidence. I'm here to tell you that with AABC and the kind of expertise that's out there in the nation and across the world, but especially here in the States, there's 1,000+ certified technicians out there right now and working for independent tab agencies through AABC. And there's probably more than 300 or 400 test and balance engineers. So there's roughly 1,500 certified testing and balancing AABC test and balance personnel in the States. And there's probably, I'm going to say, another half as many, 750 non-certified that are working with those certified people to become certified. So all in all, there's close to 2,500 people in this country that working independently, going home every day, knowing that what they put on the paper is the way it is. And I have a little statement here to the right that says success is neither magical nor mysterious. Success is the natural consequence of consistently applying basic fundamentals. So if you apply these basic fundamentals that we went through today, success is going to happen. If you don't apply those fundamentals, the road's going to be rough, rocky, and hard travel. You may get there, but it's not going to be a smooth ride. So with that, I want to thank everybody for tuning in today. We have a Tab CX Energy in 2024. That's April 30th, 2024 in San Diego. The AABC and ACG will be there. We're having a Tab seminar on Tuesday, so hopefully people can sign up for that. And there's a promo code there for signing up. And with that, I will turn it over to Karen.
Thanks, Mike. Great presentation. We have a lot of questions. I don't think we're going to get through most of them. Unfortunately, we'll see what we can do to get them answered after the fact. So I'm just going to try and pick out a few that I think you could answer reasonably quickly. Let's see. Okay, here's someone who says, the last project I commissioned, the tab work failed. What actions should be considered in this case?
So if it was an AABC firm that balanced it, you can write to AABC headquarters and ask for documentation that that project was actually sent in for certification. If it was not an AABC company, I'm not sure how you would handle it from their certification body. But me personally, the first thing I would do if there was ever concern is contact the tab agency, contact me and say, or our general manager, Jeremy, and say, hey, I have this problem on a job, something's going amiss. And if they're not immediately at the ready to make it right, be very, very concerned. There may be major obstacles on the job between personalities and people, but contact that testing and balancing company. And if you can't get action through them, contact their certification body.
Yeah, okay. Here's another one I think you could probably take care of pretty quickly. Are there good reference guides for reasonable tolerances?
Yes, the AABC standards. They have great tolerance guides in there for specifying and giving you a good accountability of what you should expect relative to tab instrumentation, like I talked about. It has its limits, but standardized, I would say plus or minus 10%. If you really wanted to do yourself a great service in a lab situation, do plus or minus 5%.
Ready? Here's someone that says NEEB does not have requirements for temperature readings. Does AABC have temperature reading requirements?
Yes, per AABC standards, temperature reading requirements are listed. I don't know the standard chapter, but it is in the AABC standards for test requirements. Absolutely. I actually mentioned that in one of the last 2 or 3 slides.
Okay, now here's one that's kind of interesting. I think this is going to have to be our last question. Here's someone who writes, we've had a couple of conflicts on testing equipment that does not have duct work. As an example, unit heaters, ductless mini splits, curtain fly fans, etc. And this person says, what's your opinion? Maybe what's your approach might be a way of understanding that question.
So when AABC has a tab standard on non-ducted equipment. Mike Kelly, American Testing, has a standard operating procedure that if it was non-ducted, we will basically go by the manufacturer's recommendations for amperage, calculating horsepower use, RPMs. So if it's a prop fan, and let's say the prop fan is designed at 900 RPM, we do basic fan law number 1, RPM 1 over RPM 2, CFM 1 over CFM 2 is a direct proportion. So if it's 10% low on RPM, it's 10% low on airflow. So by that, I would say calculated. Anything non-ducted as a summation would be calculated based off of manufacturer's data.
Great. Okay, so we're going to squeeze in one last one. I'm going to have to make this one quick. If
Sure.
the sequence of operation is wrong, who is responsible for identifying and reporting it?
That would go back to the design team. Yeah, the sequence of operations is not for the testing and balancing, nor the control. The control contractor or control agency can recommend, but at the end of the day, it should go back to the design team to make sure that it's hitting all of its points that they need to hit for sequence of operation. They hold the insurance and they hold the responsibility. So at the end of the job, they should be the ones making the yes or no on any sequence of operation changes.
Okay, well, this was a great presentation. I think that's all the time we have for questions, unfortunately. So that's a wrap.
Okay.
Thank you, Mike, for a great presentation and for a good discussion. And thanks again to our sponsor, Blue Rhythm. Our next webinar, our next webinar is on February 21st and is pre-tab for engineered designs. And as Mike pointed out, please be sure to check out the program for CX Energy April 29th to May 2nd in San Diego this year. Thanks, everybody.
Wonderful. Have a great day. Thank you, everyone.